Okay, so now we're going to look at a little more complicated example. I hope it's not overwhelming. It won't be. You're brilliant. Okay, so let's take a look here what we have. We got example 3. Example 3a. It asks me to determine binomial factors. Okay, so here's the expression I'm going to factor. Minus 3x times x plus 5. And my problem is asking me to determine binomial factors. Okay, just an important note here. Next day, like in 5.3, you'll probably view problems like this as strange. Especially when you hit 5.4. Okay, you'll view stuff like this as strange. And you'll see why eventually, but normally we don't get binomial factors when we factor GCF. Okay, but there are more elegant and well, not elegant, but just there are other ways to get GCF, or sorry, not GCF, binomial factors, using other methods. But using GCF, in this case, that happens. Okay, so just to give an understanding of what our answer is going to look like, we're going to have two binomials being multiplied together. That will be our factored form. Okay, so you remember from last day we had stuff like, x minus 3 times x plus 7, right? And we would FOIL that out and get our answer. But it's important to note that this is what our answer is going to look like. Okay, so just going to erase that because that's not actually our answer. It's just what it's going to look like. So I'm going to show you two methods for how to do this. And hopefully one of them will make sense. It can feel a little bit complicated, but as long as one of them makes sense, then we'll be successful here. Okay, so first method is just basically doing what I've been doing the entire time. All right, I try to think of the greatest common factor that I can pull out of all of my terms. Okay, so what do I have here? I've got 4 and 3. Those don't have any common factors except 1, but that doesn't get us anywhere. I've got an x here, but I don't have an x by itself over here. I've got this x, but it's being added to the 5, so that makes it incapable of being separated from that 5. And lastly, I've got x plus 5 and x plus 5. And I know this might seem a little bit strange to think of, but try to imagine x plus 5 as its own individual term. Okay, this is its own individual term. Really, it just is a number. We don't know what number it is yet because we don't know what x was, but if I told you x was like 2 or something, this would equal 7, as would this. Okay, and so it would be a term. It would be the term 7, right? But because we don't know x, just try to imagine this as its own individual term. Okay. More importantly, try to imagine it as a factor, a thing that's being multiplied in each of these terms. And when you think about it like that, you identify the greatest common factor for both terms, x plus 5. So my GCF is x plus 5. Okay? So like I did last time, I'm going to write x plus 5 in front of a set of brackets. In fact, it's going to go in its own set of brackets as well. That's important. Okay, and I'm going to divide all of my terms by x plus 5. Divide this by x plus 5. Now what happens when I do that? Well, I've got x plus 5 up top, x plus 5 on the bottom. What happens? What happens when I divide something by itself? Well, it cancels. Right? So I'll just maybe cross them out so you can see how they cancel. Those cancel and those cancel. And whatever's left over goes inside these brackets here. Right? So I'm left with, well, the 4 and negative 3x. Okay, and there we go. There's our answer. This is the factored form, the product of two binomials, of this expression up here. Okay? Alright, so how do I know that this is correct? Well, just like we did last time, we're going to multiply it out and make sure that it equals what we started with. Okay, so let's just do some quick foiling here. So x times 4 is 4x. X times negative 3x is negative 3x squared. 5 times 4 is 20. And 5 times negative 3x is negative 15x. Going to add some like terms here, the 4x and the negative 15x. That gives me negative 11x. Then minus 3x squared plus 20. And I'm just going to leave it at that. Okay. Do you notice a problem? Like I said, if I multiply this out, it should be the same as what I started with. But this does not look the same as this. Ah! What happened? Did we make a boo-boo? Maybe somewhere here, or here, or here. I don't think so. It's always a good idea to check, but have no fear. What we need to do is we need to somehow modify this to make it look like that. Right? And if we can do that, then we know we're right. Okay, so to do that, I'm going to get out some blue here. Come on, blue. There we go. And I'm going to distribute this 4 into both of these terms, and the negative 3x into both of these terms. Okay, so that gives me 4x plus 20 minus 3x squared minus 15x. Again, I'm going to add this and this, these like terms, giving me negative 11x plus 20 minus 3x squared. And you'll notice that I have matching terms now. I've got negative 11x here and here, 20 here and here, negative 3x squared here and here. So these are identical, okay, just written in a different form. So I know for sure that this is my correct factored form. This would be my answer, okay, this part here and here, that's just checking. This is my real answer. This is the factored form. Okay? Okay, so let's try this a different way here. Okay? We're going to do method 2. Exact same problem, different method. Method 2. And I'll just rewrite the problem here. I'm going to factor 4 times x plus 5 minus 3x times x plus 5. And I like this method better. Your book will use the first method, but I like this method better because I'm a big fan of doing things in the simplest way possible. Sometimes my brain overcomplicates things and it doesn't always work out, but I think this is a pretty simple method. What I'm going to do is I'm going to replace x plus 5 with a letter. Okay, I'm going to make a substitution. I'm going to replace wherever I see x plus 5 with just a letter of my choosing. It doesn't really matter what letter you use, but I'm going to use a in this case. Okay, so I'm going to let a be x plus 5 in my expression. So just to be clear, wherever I see x plus 5, I'm going to replace that with the letter a. Okay, so 4 times, well, x plus 5, that just becomes a, minus 3x times what used to be x plus 5 but is now a. Right? And if you were just to look at this problem right here and said, okay, factor whatever you can out of there, it'd be pretty easy, right? What's the greatest common factor here? Well, obviously a. It's the only thing that's common to both. Okay? So I'm going to do that. I'm going to factor the a out. And I write what's left over. Well, factor the a out of the first term and I get 4 left over. Factor the a out of the second term and I get minus 3x. Okay, I'm almost done. Now all I need to do is replace this a back with what it originally was. Okay, originally it was x plus 5. So we're going to replace this a with what it's supposed to be, x plus 5. So that gives me x plus 5. That should be going in brackets. That should go in brackets. And then the 4 minus 3x. And now we're done. Okay. So like I said, I like this method a little bit more. It's a little simpler for me. We can just compare it to what we got up here. We can see that this x plus 5 times 4 minus 3x perfectly matches our answer down here. Okay. For this next example, I'm just going to use the clip that we had from class.